Hey everyone, and welcome. Today, we're going to decode a kind of hidden language that powers, well, pretty much everything, from your morning coffee to the stars in the night sky. And it all kicks off with one simple question.
I know it might sound like a riddle, but seriously, what is the link between a simple bit of math a kid can do and the fundamental laws that govern all reality? How can those two things possibly be related?
Well, the answer is surprisingly simple. It's just one word. It's not a number, it's not some grand theory, it's all about action. The word is operator. So buckle up, because over the next few minutes, we're going on a wild ride. We're going to see how these things called operators are the secret architects behind, well, everything. We're talking about the calculator in your pocket, the device you're watching this on right now, and yeah, even the deepest, most fundamental rules of existence itself. All right, let's start at the beginning. What are we even talking about here? What is an operator, really? It's actually super simple. An operator isn't a thing, it's a doing. Think of it like this. It's a symbol that basically tells you to do something, to kick off a process, to make some kind of transformation happen. And I love this quote because it just nails it. If numbers and variables are the nouns, the things, then operators are the verbs. They're what make math jump off the page and actually do something. Okay, I know this might still sound a little abstract, but here's the thing. You use these action words constantly, probably without even thinking about it. Let's look at some operators you definitely already know, but maybe see them in a whole new light. Take the plus sign. Simple, right? But it's not just sitting there between two numbers. No way. It's an instruction. It's an operator that's commanding you to perform the action of addition, to transform two completely separate numbers into one single new one. And get this, even the good old equals sign is an operator. We usually think of it as just a statement of fact, but it's more active than that. It's like an act of equivalence enforcement. It's actively declaring that whatever is on the left side must be treated as the exact same thing as what's on the right. It's a command.
What about the less than symbol? Yep, that's a relational operator. Its entire job is to compare two things and impose order where there was none before. It's a simple little action that creates a relationship, and that simple idea is a cornerstone of all logic.
Okay, so we've seen them in basic math, but this idea, it gets so much bigger. These operators don't just live on a chalkboard. They are out there sculpting our entire world, from the logic inside our phones to the fundamental laws of motion. Think about the device you're on right now. Inside of it, billions of tiny decisions are being made every single second. And what governs those decisions? These three super simple operators, and, or, and not. These are the logical verbs that form the absolute bedrock of our entire digital reality. Kind of mind-blowing, right?
So how do we even begin to describe a world that's in constant motion? Well, that's where calculus, and specifically the differential operator, comes in. It's like a recipe for change. You start with a position, a value. You apply the operator, and boom, you get velocity, which is just the rate of change. But what happens if you apply that same operator again? You get acceleration. It's literally an engine for describing motion itself. Okay, this one, the gradient operator, is a personal favorite. It's just so cool. Imagine you're standing on a huge hill, but it's totally foggy, and you want to get to the bottom as fast as you possibly can. The gradient operator is the mathematical tool that points you in the exact direction of the steepest path down. It's the absolute cornerstone of optimization in like everything from physics to machine learning and AI. All right, so operators build our tech. They describe motion, but their most profound, most mind-bending role is at the very smallest scales of reality. This is where they literally write the rulebook for existence itself. Let's start with a really simple question. Does the order you do things in actually matter? I mean, if you put on your socks and then your shoes, everything works out just fine. Success. But what happens if you apply those actions in the reverse order? Yeah. You get a totally different, and let's be honest, a much worse result. Now, that might seem totally silly, right? But that simple logic, that order matters, is one of the most fundamental and, frankly, bizarre truths of quantum mechanics. When you're dealing with quantum operators, applying them in a different order doesn't just give you a different answer, it can give you an entirely different physical reality. It's a huge deal.
And that brings us to the king of all quantum operators, the Hamiltonian. This thing is a beast. It contains all the energy information of a system, but what it does is staggering. The Hamiltonian is the operator that takes the state of the universe at one moment and generates the very next moment. It is quite literally the engine of time. Wow.
Wow, we've gone all the way from simple arithmetic to the very flow of time itself. Let's pull this all together now and look at the grand, unified picture of what these operators truly are.
And here's how it all connects. It's like we have different families of operators, and each one governs a different part of reality. You've got algebraic operators for manipulating structures, analytic ones for defining shape and change, logical ones for controlling truth, and of course, quantum operators writing the laws of observation and evolution. They are for real, everywhere.
So if you remember one thing, let it be this. Operators are not just passive symbols on a page. They are active. They are dynamic. They are the engines that take one state of being and transform it into another.
And that leaves us with this final, really profound idea. Mathematics isn't just a way to represent the world, like a map. Through operators, it becomes a way to actuate it, to actually set it in motion. They really are the verbs of the universe, speaking all around us all the time. The only question left is, what are we going to command them to do next?